Well, good morning, good afternoon, everybody. Welcome to Building Transformations session today on data integration for digital twins. My name's Helen Goodland. I'm a member of the board of directors for Building Transformations. I'm also principal at SciUS. For those of you who have not yet met us, we're a Vancouver-based research and consulting firm here to help you with your research and innovation needs, projects, policies, strategies, whatever crazy and novel things that you might want to get up to. So today we are going to be, first of all, introducing those of you who are maybe not quite so familiar to Building Transformations. So I'll do that in the next few minutes, and then I'm going to hand it over to our key presenters. Building Transformations, we're a national organization. Our role is to drive the building and construction industry forward. We have many programs. For those of you who have explored our website, you'll know that there's a lot of things that we do to serve our members, including events, in person, as well as like today, online. We have a certification program for professionals, organizations, and educational institutions. There are numerous think tank groups that are for different segments of the construction and building industry. And we have our annual awards program, our publication and career posts, and much, much more. Our membership and audience continues to grow. Right now, we're over 2,000 members across North America, Canada, and the US. From diverse areas of the industry. So please follow us on LinkedIn to stay informed about what's new at Building Transformations. And you can go to our website, buildingtransformations.org, for more information and to sign up for our newsletter. We've got lots of materials on our YouTube channel. In fact, we record a lot of the events that we do so that you can go back and check them out. And it will give you a great idea and taste of some of the excellent content that we provide to our members. We're a growing community right across North America. Membership options are available for both organizations and individuals. We have companies that can join as an organization based on different sizes from small to large. One organization membership will get you your whole team with affiliate memberships that will give them access to all sorts of member discounts across all of our events, access to join the think tanks, and access to member-only events, content, and so forth. We also provide opportunities really for organizations of all sizes, from startups to global enterprises. And you can read more about the kind of work that our members get up to in our annual publication, which is available online for free, and it's quite a lovely glossy magazine that you can acquire for purchase in print format. So a little bit more about some of the events that are coming up. The big one, please mark your calendar. For the remainder of this year, we've got the Future of Design and Construction event in Toronto this October. You won't want to miss it. There's all sorts of powerful speakers from PCL, Ellis Dawn, Sinai Health, the Department of National Defense, and more. There are a few tickets left, so please go check them out and register on the website. And then finally, looking ahead to 2026, there are events running right across Canada and the US, so please again check out our website for more information on those. Finally, as you were coming into the session today, you saw a sort of scroll of all of our different mission partners. A huge thank you once again to all of them. We could not make this possible without you. So again, a big thank you. So now I want to turn our attention to the main event. And with that, I want to introduce our two speakers today, who are from Bird Construction. So first of all, I'd like to introduce Tana Clark. So Tana is the Director of VDC and Digital Construction Services in the Industrial Division of Bird. Tana has over 30 years of experience in development and application of digital construction methods in the construction industry. He possesses that rare combination of skills and knowledge that in the built environment where it's filled with constructors, designers, and managers, Tanner is able to move seamlessly from one role to the next as he has practical construction experience, a working knowledge of the leading design software tools, and experience constructing facilities and infrastructure both virtually and digitally, and we're going to hear a lot more about that shortly. He has implemented a wide range of design software tools for large and complex projects completed in both public and private sectors across Canada and around the world. Tanner leads the field by creating progress through innovation and the practical use of leading edge technologies. His focus on digital twin applications across industries has driven new ideas in how data can be utilized in an effective way. Tanner has been speaking at various industry events, opening up others to the extensive application of digital twins in today's marketplace. Joining Tanner will be Dillon Shepherd, who is the Digital Construction Manager, also in the Industrial Division for Bird Construction. Dillon has special expertise in the implementation of digital twin technologies. Within the built environment, he supports building owners, developers, and construction companies in bridging the gap between physical asset and digital intelligence, ensuring that organizations are positioned to maximize efficiency, reduce costs, and enhance long-term asset performance. He has a strong background in business strategy, technology enablement, and Dillon provides structured leadership in guiding organizations through every stage of digital transformation, from strategic planning and design through to deployment and operational integration. His focus is on delivering measurable outcomes while maintaining alignment with organizational goals, industry standards, and best practices. Phew, you guys, that's a lot. So we're looking forward to a very rich presentation. For those of you online, you will see that there is a chat comment section. We will hopefully have a few minutes at the end of the session to take some questions. Please type your questions into the comments, and I will do my best to field those. So without further ado, Tanner Clark and Dillon Shepherd, it is over to you guys. Take it away.
Thank you, Helen. So as Helen mentioned, we're going to be talking today about data integration for digital twins. Dillon and I have worked together for years developing ways to integrate the data that we all use on a daily basis in a more intelligent and direct way. So we're going to go over some of the agenda items: our data integration overview, introduction to what a twin is, the importance of the data integration, how a twin integrates data, where those data sources are from, key benefits of integration in a digital twin, and the implementation of iTwin integration. And then we'll look at a couple of examples and what the future looks like. So the data integration overview provides us with a unified source of truth, which we've all heard numerous times. It's that one source of information so that we can pull and push to one location. Digital twin integrations, it being that unified source of truth, it aggregates all engineering data into a single twin, enhancing collaboration and data accessibility. It allows us to break down the silos that are traditional in this industry and across others, enabling teams to access and utilize information more effectively across different projects. So repurposing some of that information that we've used over and over again, rather than having to re-input and reorganize every single time. A vendor-neutral solution, digital twins require this to be vendor-neutral, as we need to be able to access information from all sources. So a vendor-agnostic framework allows with their preferred tools while integrating seamlessly into one model or one data source.
So part of that vendor neutral integration should allow us to get real-time data updates. And that really means that we're not locking ourselves into any one ecosystem. We want to be able to look at information, whether it's from the facility or assets on a project site. That may be a crane, heavy equipment operations, weather data. we really want to make sure that we're curating an accurate representation so that when the stakeholders go to engage with this information, they have as much information as possible that is being presented to them. And again, we're going to reinforce that it does need to be the vendor neutral approach. Too often we see custom built solutions that don't always play well with others, and that can be very limiting in the ability for other stakeholders to come and be a participator in a digital twin. Next one.
So the digital twin platform itself, as Dillon said, it's got to be vendor neutral, completely connected, so that we can unify the project data. Again, eliminating the silos that traditionally that we experience in design and construction, everybody working in their own area without the direct communication and the direct connection with all other aspects. And I'm not just referring to a architectural, mechanical, structural disciplines working together. It's also estimating and finance and accounting, operations, site and in office, all need to work together to make a digital twin, well, to create a digital twin and then be able to hand that over to the owner. We also need the real-time analytics and monitoring platforms to be connected fully into this as well. So being vendor neutral, allowing integration of data from various vendors like Bentley, Autodesk, Esri, Hexagon, and all others that are out there is imperative. The dynamic real-time model, allowing us to look at all the sensor data and design changes as they come in and be able to make it so that rather than reacting, we're being proactive with what we see, be able to respond very quickly and coordinate with all parties. The comprehensive visuals that this allows, not just in what we see for 3D models and the data behind those, but we can also do our reporting and dashboarding to track every aspect of a project or every aspect of a product for our owners.
So for this, I like to use a sandbox analogy, and that's, I'd say, pretty common for situations within the construction space. So one of the things I like to throw around is like we will have CAD models and some sensor data that would say, let's go with some civil work. You're going to have some topography, some surfaces there, and maybe some sensor data from equipment that's operating on site. Being able to bring those into one common place allows you to make a much more informed decision, but also typically where we haven't seen those things, that they operate separately, or maybe somebody who's strictly operating from an authoring situation, that limits the team's ability to realize all that information. So instead of isolating them, this allows all of those pieces to come together and the collective whole to take advantage of that. And that really becomes important when you want to be dynamic. A lot of times we see situations where models or data doesn't get updated with enough punctuality, so the delta between what's actually happening and what's been recorded falls apart, and that can limit the value that's realized on doing work like this. And that really just continues to push for the open source flexibility, in the sense where we want to be able to not only ingest that information, but when it comes time, if we need to share it, the sets of information outward, we have the ability to do so.
So the importance of data integration. Again, back to the problem, the main problem that we all experience is the data silos, and we are trying to break that down and have been for years. But scattered project data is a common issue. We have various platforms and systems, and individual companies will use their own system. The importance of bringing that all together in an intelligent way, and a twin allows that integration to come in through multiple sources into one platform to display it as a coordinated, complete solution and complete look at what a project might be or what a facility might be in its operational state, as well as during construction. The manual data integration, a lot of people do spend a lot of time, as I mentioned earlier, re-inputting things that we have utilized on projects already. An example might be a pump or an HVAC unit that will have 8 different vendors. They have all a very similar specification. So the data behind them is common. The vendor name might be different, but we can actually utilize that information over and over again rather than having to collect it every single time. And that repurposing of data and of product information, not just for purchasing and budgeting purposes or installation sequence or installation procedures, but also for the financial side of it, having that list of vendors that provide a similar deliverable for a HVAC unit, the same specification, having that housed so that we can easily access it speeds the path of construction, the path of design with that repurposing. It also allows the owners to very easily, and operators very easily, switch out information, knowing that the commonality between specification of a pump or a HVAC unit is going to be the same regardless of vendor, and they can find the right product very quickly and replace that in again in a proactive way. Again, with siloed information, you do have the risk of outdated information being presented to project teams. A twin allows that the resource of multiple products in the background to be updated real time. You can actually connect directly into a vendor's database, have them feed the information on warranties, manual specifications back into a product data set that we can then access, and we can be guaranteed that it's always up to date based on that vendor itself. Obviously, that can help speed up everybody's role when it comes to estimating, understanding the right product for the specification to be selected, and many more things.
So what are some real consequences of those silos? One of the largest ones that we see when twins are not used properly would be the inefficiency in the access of information. So a lot of that, I would say, leans in towards the initial setup of a project and building out your twin environment so that everybody knows how to contribute and everybody knows how to extract the value that they need out of that environment. We've also seen that there can be the inconsistency across different departments. What we found over the years is there is a very common set of data that a lot of different departments use. However, they get stuck in acquiring it in their own way instead of looking to a more centralized approach, which allows them to rely on other people that are contributing along the path. Where the missed insights are is the fact that the time frame from when that information gets published to when it's realized by those people that are relying on that information. We work in fast-paced projects. There's always moving targets, and that's where the losses happen. So we really want to see a unified data solution where we're not tied to anybody, one in particular, especially in the technology space. There's always moving targets. Things are always changing and improving. So it makes sense to not put yourself into one corner.
So how to integrate that data, being that it comes from 3D models, 2D drawings, reality data, documents, forms, specifications, contracts. The central overview of the data ensures that all project data is stored in a compatible format, and it's not necessarily compatible with one or another solution, but a digital twin brings it all together under one umbrella to be able to access from multiple solutions. The connectors act as translators between various source formats, allowing us to literally connect directly to a 3D object or a representation, whether that's 2D or 3D, or even a line in a contract to define what it means, what it relates to. And when I think of the connectors in my brain, it's like a spider web of little points that connect back to each other, to other sources, and then back again. And it's just a consistently expanding set of data connections. Synchronizing the process or synchronizing the information allows us to make sure that we always are updated for any changes that are happening. And we do this as close to real time as possible, making sure that we preserve workflows to continue those in those native applications while integrating their output into and back to the 3D model to be able to describe what is going on today and what can happen tomorrow.
So, I mean, a big part of this here is the ability to track that. And that's the value of going to a centralized model in that sense, where you're going to have those recorded transactions from all the different stakeholders along the way. You're going to be able to do free snapshots and compare progress or changes over time. I think one of the not talked about values comes with your data alignment techniques, where I see the conversations changing from what type of program you use to what is the information that's of value, what helps me make decisions, what enables me to be efficient and effective. And that's really where we're going to see a lot of effort, I think, in the next while about making sure that everything is aligned so that we'd have something in a known place over a given period of time, and you have the ability to pull within that information and have a deeper insight.
What are some of those data sources? We've touched on this a little bit already. Again, the integration of multiple sources of data, and it is very important to be as agnostic as possible with the information. So choosing a platform that allows that connection to essentially every and all software platforms and file types that exist allows you to actually integrate everything into one common database. Those sets of information, and we'll have another slide ahead here that explains a little further, but it can be geographic, structural, operational, again, design, weather conditions, the traceability of components, so from source to or manufacturing source to how it got to us. These are things that owners are starting to look at and want to be able to analyze and understand in a more effective and direct way. Also using GIS data, obviously CAD drawings, financial data, and sensor data, all of which enhance project insights, allow better reporting, better tracking of where we're at, both in performance and in the financial aspects of our projects.
So, I mean, what do you really need your twin to do? I mean, we've said it a few times, but again, bringing all of your different data sources together, and whether that is, 3D related, 2D related, just lines of data, all of that stuff needs to be able to come in. We see a lot of opportunities there with different sets of operational data that gets generated from the various departments being able to be referenced back into your twin. And that's really going to drive a lot of insight for your organization or organization's stakeholders to be able to maximize their efforts and understand what's really going on. On the design and building information modeling, I mean, there's great opportunities there for a lot of the mainstream ones to come in and participate. Where I think we're seeing a lot more is the ability to take advantage of your reality data and the ability to analyze that information further to blend the intent and the actual into one seamless view.
The geospatial data integration of that aspect of our projects as well, context-rich visualization of projects on a map across, and one of the things we're attempting to do is demonstrate all of our projects across the country in a Google Earth type environment, allowing people to understand the context and location of some of our projects. And at a higher levels in most of our general contracting companies, the senior leadership understands what projects we're working on, but this would allow them to dive in deeper into provincial or even city-based project data and performance to make sure that we're able to look at every aspect of the project. Obviously, integrating more GIS data helps all of our project teams on site to ensure that we understand all of the conditions that we're going to be working in. The sensor data, as Dillon was mentioning, is definitely one of the more utilized and spoken about aspects of what we're all doing in construction today. The ability to, as he said, combine the intent from the 3D models, from the design information, overlay the scan data that comes from the real world and what we've actually done to ensure that what we've built matches our plan and be able to help track our progress and efficiency and workflows as we progress through our projects. The operational technology and merging that in with all of the model information, the data behind it, and the idea is just to take full advantage of all the data we have, the specifications of various products that are performing in the projects, to allow the operations and maintenance teams for the owners to see not only in real time, but have the ability to predict when things are needing to be maintained, replaced. As we use an example all the time of a pump might be operating at 50% capacity. If you know that, then you don't have to maintain it for a longer period of time. And that type of information is highly valuable to owners today with the cost of things, as well as getting the best use out of the products that we've put into their projects.
So, I mean, one of the ones that I see more not being taken advantage of is the linking the documents to the models. There's a ton of data that gets generated in our more traditional 2D or PDF formats, but there's a lot of data to be gleaned off of that and referenced back into those models. And that can help a lot of different stakeholders engage with what they need to do, whether you are operating that, like Tanner was talking about. Maybe you're doing your maintenance and repair and you want to make sure that your work procedures are correct and up to date and in compliance, so you'd be able to reference those things. There's a lot of different opportunities there that I don't see fully being taken advantage of. And then if you want to look at your asset management side, that's really what we want, is that, as a stakeholder for somebody who's operating a building, you want to make sure you're getting your best bang for your buck out of your assets. So this will give you those insights if you're high on your maintenance costs, or if you're not seeing operational performance, then you have the tools and abilities to look at those things in a holistic view. And that really lends itself to like your 4D and 5D simulations, where you're going to combine a set of data against a period of time with the 3D objects, and you're going to figure out what's going on in those scenarios. And that's really where I think there's a lot of value that's yet to be realized, is that allows typical stakeholders who may not have had access to this kind of information to come and be a participant in that space.
So what we have available to us, pretty common across the construction industry: project schedules, 3D models, reality data, the tracking aspects, and the document comparison and tracking, obviously our costs, ArcGIS data, quality inspections, commissioning information, and instructions, maintenance and repair, and operations, and then the IoT and sensor data. One of the things that a twin can help do with all of this information is it can help to streamline how we interact with it by automating a lot of the traditional work that we do. As an example of that, a project schedule can be automated if we know what the parts. Again, I'll use an HVAC unit as an example. We've installed HVAC units for years. We know the product information. We know how long it takes to get it shipped to us. We know the weather conditions on installation days, whether it's an interior or an exterior HVAC unit. We can house that information to predict the length of time that it's going to take to install for a long list of trades, because we've had various ones do it over time. We can take an average of that, and we can literally self-populate a project schedule with this information, which allows it to not be missing. It removes a lot of the human error or the human omissions of information, and it speeds up the costing data behind that, the time that it's going to take, the equipment that we would need on site to be able to do those installs. Just provides a tremendous data set for us to be able to glean from and repurpose, helping us to automate a lot of this process that we employ on every project we do. The key benefits.
So really the big thing that we're presented over the course of today so far is the 360 project view. I think that as we get further down this road and you see more and more of the content become available, the value of the twin will ultimately reign paramount, and people will realize that they can have a whole 360 view and be very situationally aware of what is going on that they're responsible for. Accelerating issue detection. One of the things that we've seen over the years, and this is just proven out through like the course of clash detection, is the more people you have able to view it and scrutinize it, the better your outcomes are likely. You have a wide variety of team expertise, and stakeholders look at things differently. So being able to get their engagement and their input earlier on, making it an appropriate place for them to do so, that's where you're going to really get that value back out of it.
So obviously having access to this type of information drives better decision-making, data-driven decisions when we're looking at all factors associated to the installation or the manpower required or the financial requirements that we've experienced in the past. Being able to reuse that information to make better decisions, having the real-time insights from, again, sensor data that we can have on sites. There's a lot of AI that's being implemented for safety applications, making sure people are wearing their PPE in certain areas, how many trucks are coming on and off site. So access and egress on projects, ensuring that we know what's going on at all times, but also we can do progress tracking from cameras these days, which we can then feed back into a 3D model or a 4D schedule. Enhanced collaboration, again, allowing everybody to access the same set of data and information into one unified source, where all parties can access the information based on what they need to see. It breaks down the communication barriers and speeds the progress of all communication on the projects and solves problems a lot quicker. And again, that shared model access in one location just makes it easier to resolve all the issues that we do run into regularly. Have people have a conversation that is related specifically to that issue, removing all the clutter that quite often we have surrounding certain things that we discuss to resolve problems on our projects.
There's a question there from Sergey. He said that there. Happy to answer that if you want.
Yeah, go for it.
So for your question, Sergey, does iTwin support the LLMs? I believe so at this point in time. Realistically, when you're looking at your set of data, the iTwin methodology is open source. So what we're really looking at is just data organization and management. And so when you're looking at your LLM to be able to query that, it would make sense if the information's available there, you'd be able to use that against your LLM.
Just to add to that, I would say that again, choosing a system that has the ability to access any data source, you would be able to pull the LLM information in, access it, make sure that it's accessible and specific to the relative information. Again, the whole idea of putting this information in as a twin is where if you have a component, the component is the representation that is visual that everybody can understand. A pump looks like a pump. The data behind it is where everything gets messy and confusing because different aspects, different specifications, different requirements for outputs are all unique. Being able to access that in a focused way and have the information and data and performance data all accessible through that one visual just makes everybody's life easy. As to, we all know what we're talking about. We know that there's options, but we can filter down those options and get to an answer in a much more direct and quick way.
So on the enhanced collaboration side, efficiency and time savings is always a hot topic, I think, for most people in this space. One of the things that I look at is the effort when it comes into enabling different people on the project to go and do their analysis or their contribution in the project. And by taking this approach and centralizing that all the data that gets associated to those objects, that expedites those opportunities and allows for, I'm going to go into the real-time monitoring. You have opportunities for like workflows, documentation that can be imported from your third-party sources that allow the people that are engaged in that to realistically be very empowered, instead of the front end side where you can lose, hours, if not days, just trying to procure the information so that you can complete the exercise. And really that is a risk reduction strategy. It allows you to be more proactive instead of reactive in those senses. I think one of the challenges we might see coming forward with this approach is that the things that have typically passed or happened in the past are going to come to light, and there's an opportunity for people to grow and change those things. And that's really going to change your risk situation.
Efficiency and time savings, as Dillon was just mentioning, it's the ability to see the information so that we can act accordingly in a real-time situation, or as close to real-time as possible. In a digital twin, every change is tracked. It's all connected back to a single element, and that element is connected to the project as a whole. So we can see how it interacts with other systems, how it interacts with the construction phase, the operational phase. It just really speeds everything up and provides everybody with the right information at the right time, enhancing how we work. The innovation opportunities, by centralizing data, it allows for advanced analysis. And that doesn't just mean analysis of a product and how it performs. It allows us to go in a deep dive into our projects and every aspect of it. So how I've described it is, I think that the biggest way a digital twin is going to change our industry is it's going to change the conversation from how much and how long does it take for you to install this or build this. It's going to change it to how can you do this better than your competition in a more effective and streamlined and safe way, because everybody will have this information at hand. So cost and time become a non-conversation. Those will be predetermined based on historicals. And then obviously the optimization opportunities via AI and machine learning, ever enhancing, ever growing, and the future is going to be highly automated. Obviously, we need the people that understand the systems and the processes behind it to make sure that AI and machine learning is looking at things in the correct way. But it's going to provide a lot of opportunities for automation and streamlining how we all work. And then continuous improvement and training, integrating data from the twin supports continuous improvement. And it allows us to actually simulate training by utilizing visuals and interacting with things, and like using tools like AR, where we can overlay the real world and the 3D models in one space. We can actually take for operations, we can take a maintenance program and simulate that utilizing AR, so that we can take individuals step by step through what it would take to maintain a pump, an HVAC unit, a nuclear facility. It really wouldn't make a difference. You're just overlaying the model information into the real world where you can take people through step by step and allowing them to follow a training exercise to ensure that they're doing it right, not only the first time, but every time.
There's a couple questions here, Tanner.
Yeah, well, we're just about done. Do we want to hit those questions now or just finish up here and then we'll circle back?
So, here's a perfect real world example where we've got the IoT sensors tied for vibrations and other things into the dam. And that's really valuable for them to understand the performance of the dam. We've seen other opportunities there through the use of, drone flights and that allow us to track and manage cracks along the dam, being able to engage earlier with the client around maintenance and repair requirements. And ultimately, our real big goal here is about safety enhancements overall. This allows us to be, again, proactive instead of reactive in this scenario.
The dam example we're looking at, one of the things that they were looking at for this project was cracks in the surface and monitoring whether they're moving or not, whether they're getting bigger or they're not moving at all. Obviously, very important information to the maintenance of a dam surface that's holding back tons of weight. Other project examples at scale, there was a city in Gowanus that essentially a digital twin was created and various data models to aid urban planners and stakeholders to not only understand what was going on, what they had, but to be able to plan for their future and in multiple aspects, traffic flows, energy usage, so on. So it's a pretty impressive. There's been some pretty impressive applications so far in the industry. They're ever growing, and I haven't seen personally a full use of a digital twin to date, but there are certainly areas of the world and some cities that are working towards that in a real way. Again, urban planning decisions can be made, transit routes, and this is becoming a more mainstream request, especially in the industrial sector. I'm seeing most of our clients ask for a digital twin today. Whether they understand completely what that is and what that means is a different conversation, but the adoption is definitely helping to streamline our operations internally for general contracting, providing our owners and clients a much better idea of how their projects are operating, and it gives them insights into how we operate to be able to coordinate and communicate from napkin sketch right through to decommissioning of their projects if we're involved for that length of time. So that is our presentation. And yes, there's a few questions here. So I can answer we can answer the ones that we see on screen here, but Magdalena asked, what kind of digital twin visualization tools have we tested and what made us choose the one we're currently using? And so we looked at a few different platforms, but we chose, for the industrial side of Bird, we did choose Bentley. And the main reason we chose Bentley is because it has a plethora of products that we have access to under the platform. So it acts more as an umbrella for products that we can use in design, operations, the IoT sensors and managing the information from them, connecting our contracts, our schedules, every aspect of what we do and the information we work with. It made the most sense. Price is always a factor, but the reality is it was the most powerful solution that we found at the time. There are a few other competitors that are pushing the same boundaries, but this was the one that made the most sense for us.
I think for me on the con side of that would be the need for the work to be done properly in a coordinated space. There's still a lot of opportunities for work to be done not in the right space, and forcing those people to move into the correct location so that the full exercises of, de-risking projects and coordinating them really gets realized. It would be the hard part of that. Once we've gotten them on board, the ability to move fast and efficiently greatly improves. For the question for Carla on that one, we definitely do see a lot of clients that require their data to be entered into their systems, and I mean that's still I would say an ongoing challenge. One of the things that I see us looking at is the fact that majority of that is just a data communication exercise. So that conversation needs to improve to instead of it being just that, we can look at a handshake agreement of, what information can we share? What information do you need? How does it get given to you? We spend traditionally a ton of people power to make that happen when we have a really good source of truth and a set of data that can be used to enable that.
Just a quick addition to that, as an example, project schedules are quite often something a client would like in a particular piece of software. The tools that we use are bi-directional, so we can work within the tool we have and literally save it out as the client-driven request, and it becomes a non-issue.
Can I just ask a quick question on that? Given how much data flow you've got going backwards and forwards in and out of your digital twin, how do you manage for accuracy and how do you check for reliability? Because obviously there could be a whole bunch of garbage going in and out at the same time.
That is a challenge still today. We do. It's been there's some very powerful tools that allow us to do the comparisons between versions and iterations, and that helps along that. However, there's always a possibility of something being entered incorrectly and not caught. And if it's brand new, it's not being compared to anything else. So it's important to scrutinize the information as we go through it as well. So it does take the human to look at the information, look at the data sets, ensure that it is relevant. Yeah.
You do have a lot of questions here. I'm just looking at the time. It's like we've got 5 minutes or so.
For Sushant, I would say at the beginning is always best. However, it's never too late to start. What I think you'll find, at least in my experiences with this, is you'll find out what is not in alignment and allows you to put pressure in those areas.
And for Matthew's question, people are calling a model a digital twin, very similar to when people were using Revit, they called it BIM. It's the same concept. A model is not a digital twin. A digital twin truly becomes a twin when you have every single piece of data behind the products, behind the process, behind the contracts, completely associated to that component that creates the digital twin. It's beyond what manufacturing does right now, but manufacturing would be a good example of a part could be a digital twin if every aspect of the data behind it is connected to it.
Just jumping in very quickly about the question about sharing the presentation. This whole session will be uploaded to YouTube, so everyone will be able to go back and review all of the great insights from today as well. Sorry, jump back in.
No problem. I'm going to have a hard time pronouncing this name. Karsh? I'm close. The multiple changes and sources becomes not a problem when you have everybody connected into the one system. If everybody's feeding into that single data source, it's less of an issue for any changes that happen based on client requests or added scope. We're literally adding to the common data set. So it just expands upon it or modifies it along the way. It's more of a real-time type of thing. And then we got one last question, or maybe it's just an expansion on that previous question from Matthew. Hub versus repository. Yeah, we're using a Azure data lake type of platform for the data itself. The idea is that we really need to manage the feed back and forth and limit the transactions that happen. And that's one of the things that is a bigger deal of having this much data. Data transferring back and forth between systems can cost quite a bit of money, and managing that to only feed what is necessary back to the common data lake or the data set that we need to refer to and feed to build our bigger repository, versus what we need to interact with on a project level that does not need to get fed back there. There's a lot of criteria that needs to be followed to make sure that we're not frivolously pushing information back and forth just because we have it. It's got to be very well organized and scrutinized to be able to save that money and time.
That's awesome. I have one question for you guys. Clearly this has been a journey of some time and effort from Bird's perspective to get to where you are today. If you were providing advice to a smaller construction company that was just embarking on this journey, what would you say would be the kind of key steps and maybe a pitfall or two to avoid?
I think for me, the biggest thing is don't get caught up living in your past ways of being successful. There is opportunities there for really big wins. You might fall down along the way, and that's okay, as long as you're falling forward.
Yeah, I agree. The fail fast methodology. The technology changes so rapidly. And especially today, it's 5 years ago, it was not this speed of progression. Today, we are able to take advantage of systems and, things like ChatGPT or the Gemini system. It provides a huge resource of industry and global knowledge that we can all take advantage of. When you're choosing a system as a smaller company, you want to choose the one that fits your company. And there's a plethora of them out there. You don't have to apply every piece of one system. That would be my biggest recommendation. Just because one company says they can do it all, don't take it all.
That's very wise. Thank you, guys. We are really at the top of the hour now. Thank you again for your time. Thank you very much to everybody who stuck out right to the end with some great questions. Just a reminder that this session has been recorded and that it will be joining the wealth of great content on the Building Transformations YouTube channel. So please stay tuned to see that, and then you can share. I want to say thank you again to our sponsors for today that made it happen. And please join us again soon for the next one. So thank you again, Tanner, Dillon. Fantastic presentation. I learned loads.
Thank you, everyone.
So yes, thank you very much again, everybody, and we'll see you very soon.
Thanks.